Hey, welcome back. All right, today we're going to be multiplying and dividing monomials. Huh, who knew? I guess you did because you read the title, right? All right, let's get to it. Ain't math fun? All right, let's start with the simple one just so I can go over a couple of the rules. So let's say we have 4 to the power of 3, and that's being multiplied times 4 to the power of 2. Okay, so we got that right there. And so now my pen isn't working too good. What's going on? Hold on a second. All right. So I'm gonna break it down so you can see what this actually means. So if we take 4 to the power of 3, what this means is that I have 3 fours. 1, 2, 3. And they're all being multiplied together, right? This means I have 2 fours being multiplied together. 1, 2. And of course you can see right here that both of those are being all multiplied together, right? So this section right here times this section right here. Well, simply, if we can count 1, 2, 3, 4, 5. I have 5 fours, so you can say that you have 4 to the 5th power. Does that make sense? Now, I wanted to break it open so you can understand where this is coming from. So essentially what we can do when we have these problems right here, 4 to the power of 3 times 4 to the power of 2, something similar like that when they're being multiplied, you can actually say that you have 4 to the power of 3 plus 2. So now you can see that all I'm doing is adding the exponents right there. And my final answer would be 4 to the power of 5, right? Just the same as I had, down here earlier. All right. So hopefully that makes sense to you. And that's all there is. When you're multiplying numbers with the exponents or variables with the exponents, as long as the base is the same. Notice my base is 4 on both of them. As long as the base is the same, you can add them. If the base is not the same, do not add them. That's that simple. All right, let's take a look at another example here. First, let me clear this out. All right. So next example, 2x right here. Right. Oh, I forgot to tell you, always make sure you're writing this down, all right? Write this down. These are excellent notes that you can use to do your homework and other classwork assignments. I let my kids use notes on their tests. I don't know about your teachers, but that's what I allow my kids to do. So here we got 2x times 3 times a to the power of 4, right? Now, what do we have here? Let's break it open so we can understand. We have 2 times x, right? That's the first part here. And then right here, what do we really have? We have this being multiplied times 3 times a to the power of 4. Notice that a is the only one to the power of 4, not the 3. The 3 is just by itself. So what do we really have now that we're going to, oh, you know what? My bad. This shouldn't have been an A, okay? So sorry about that. This right here, okay, it doesn't want to erase. Why not? That right there should not be an A. It should have been an X. So my deepest apologies. This should be an X right here. This should be an X right here. Or else, what's the point? All right. That would be the final answer if that was an A. So now all we do is combine like terms. So we can see that we have 2 and we have a 3. So let's order them so we can see what we have. We have 2 times 3 times x to the power of 4. All right. That's what we have. So let's simplify it all the way. We have 2 times 3, which is going to give us 6. And then that's being multiplied times how many x's? We got 4 x's right here and 1 more x right here, all being multiplied together. So we have a total of 5 x's being multiplied together, which is right there, x to the power of 5. So 6 times x to the power of 5. That's all it is. All right. So sorry about the little mistake with the A. All right. Let's move on. Let's take a look at another example. Hey, I just noticed I erased the title. I don't know what's wrong with me today. But this one is very similar to the one we just did. So we have here 2x squared times 3. This one throws people off. Again, I'm going to spread it open so you guys can see what we have, and then I'll show you the shortcut on how to solve it real quick, all right? So we have 2x squared. What do we have there? We have 2 times x times x, okay? So what is this 3 telling us? This 3 is telling us that we have 3 groups of this, right? So this would be my first group. I have 2 more groups of this. So 2 times x, and then 2 times x times x. There's my 3 groups right there. All right. So hopefully that makes sense to you. Let me see. Can I move this? Yes, I can. Look at that magic. All right. So again, from this point, if you break them open like this, all you have to do is count, right? So how many 2's do we have? We have 1, 2, 3. We have 3 2's, so that will be 2 to the power of 3. And then how many x's? 1, 2, 3, 4, 5, 6. 6. So x to the power of 6. I know I'm counting the x's, but each x, we don't write it, but each x has a power of 1, right? So it's actually the exponents that I'm counting. I don't want you to think you should have written 6x. It's x to the power of 6. Now, if these x's would have been added together, then yeah, it would have been 6x. But no, they're being multiplied together. So it's raised to the power of 6, right? And this would be my final answer here. I can't go any further. But let's take a look at the shortcut. What can we really do? Okay, so since this 3 right here is being distributed to all of this, basically it is 2 to the power of 3, which would be this, 2 to the power of 3. And then right here, we have an exponent of 2. So these 2 exponents can just be multiplied together, and you would have x to the power of 6, because 2 times 3 equals 6. And there you go. That's your final answer. So if you can remember what I just told you, that's the fast way of solving it. If you forget because it's something new, then hey, spread them open like that. Spread everything open so you can clearly see what you have. Remember, I've been doing this for like 20 plus years. So yes, it's going to be easy for me. But in the beginning, no, it wasn't. All right, so let's take a look at another one. Actually, how about we look at some division? All right, so that's multiplication. Essentially, if you can learn those rules, you'll be able to solve all of them. So let's take a look here. We have y to the power of 3 over y to the power of 5. I hope you know by now that all fractions are actually division problems, right? So that's what they are. So it's y to the power of 3 divided by y to the power of 5. Again, let me break it open so I can show you what's happening. We have 3y, so 1, 2, 3, and all of these are being multiplied together. And then we have 5 here. 1, 2, 3, 4, 5, and all of these are being multiplied together. All right, so how do we solve this? Easily. So we're going to divide y divided by y right here. So y divided by y equals 1. Not 1y, just 1. Y divided by y here equals 1. Y divided by y equals 1. So these are giant ones here, right? Don't think that they cancel, because canceling makes me think of zeros. So it's not 0. It's 1 times 1 times 1 is what we have there. So what do we have all in up here? Out of all those ones, it's just 1, right? So I'm going to go ahead and write it up here. Now here, what do we have? Y times y. Excellent. So we have y to the power of 2. And that right there, ladies and gentlemen, would be my final answer. All right? I hope this makes sense to you. Now, here's the shortcut. Now, it's not really a shortcut. It's the way we do math. It's what's really happening, because division is really repeated subtraction, right? So let's take a look. We have y to the power of 3 over y to the power of 5. And what you want to do is you always want to keep the exponents positive. So you want to take the small one and always subtract it from the large ones, right? Like they taught us in elementary school. So what we're going to do here is we're going to take this, and we already have y to the 5th power right here. So I'm just going to rewrite that, y to the 5th power. But since I'm bringing this one down here, right? I'm not taking the whole y. I'm just might as well take the exponents since I already know the base is the same, and I'm going to subtract the 3. And that right there, what does it leave up there? Remember, it doesn't leave a 0, right? It left a 1. So this up here is going to be a 1. So what do we have? We have 1 over y, and 5 minus 3 is 2. Okay? Notice, same exact answer. All right? So that's the fast way of doing it. It's just taking the small exponent and subtracting it from the large one. All right? Hopefully it's making sense to you now. All right. Let's take a look at another example here. We have 24 x to the power of 4. And that's going to be over 6x to the power of 7. All right. So we got a 4 there and a 7 here. Okay. Again, just so that you can see, I'm going to break it open right here. So we have 24, and I'm going to write the 6 right underneath. And I want you to think of these as sections here. So I got that. And then here, I have the x to the power of 4 and x to the power of 7. So simply I can write x to the power of 7 minus 4, right? Remember, up here, it's going to leave a 1. So that's what we have. So, simple. Let's simplify. What is 24 divided by 6? Well, that's going to be 4. And then here, all I have to do is 7 minus 4, which gives me 3. So I have 1 over x to the power of 3. All right? And that right there would be my final answer. That's it. So whenever you get whole numbers like that, go ahead and divide them or simplify them at least. If they cannot be divided into something even, you don't want to write decimals here. Simplify it all the way down. Pull out the common factors. All right. Let's take a look at the last one. All right. You should be an expert by now. All right. I hope you're writing this down. If I'm going too fast, it's a video. Pause it. It's a video. All right. So here we go. We got x to the power of 6, y to the power of what? 14 all over x to the power of 4 and y to the power of 9. So how is this going to look once I subtract them? It's going to look like this. X to the power of 6 minus 4. And that's going to be over, actually, it looks like the two small numbers are at the bottom. So I'm going to take that 9 up there, and it's going to be y to the power of 14 minus 9. That's what it's going to be. So what's left at the bottom? No, not a 0. I know you didn't say that, right? It's a 1. It's a 1. All right, so what do we have left here? 6 minus 4 gives me 2. X to the power of 2. And then y to the power of 14 minus 9 gives me 5. Okay? And that, ladies and gentlemen, would be my final answer. Yeah, we did it. All right? That's what I'm trying to do. Get them out here to you as fast as possible. I hope you got some value out of this. And if you did, come on, subscribe to the channel. Who's going to give you better math than me? Nobody. All right. Hey, you guys have a great day. And I'll see you next time on Math Quiz. Take it easy.